Welcome to the product demonstration of wireless vehicle charging system for EV vehicle. In this product we are using step down transformer and a bridge rectifier, MOSFET board and Arduino Uno and capacitors board, and also using transmitter coil here you can see, and also using receiver coil and rectifier, voltage sensor and PIC microcontroller, LCD display. So the main aim of this product is to implement wireless charge for the electric vehicle. So how wireless system will be works? So we are providing the power supply for this system, mainly two supplies. It is for the Arduino microcontroller and it is for the transmitter coil. So here we are using adapter. It takes 230 volts of power supply and it will give 5 volts of DC. That 5 volts of DC will be utilized by this Arduino Uno. And here we can see it is a power cable. It takes 230 volts of power supply. It will given to this step down transformer. It will step down up to 230 volts to 24 volts. So that 24 volts will be given to the rectifier. So we know that rectifier converts AC to DC, then it will be convert up to 50 volts of DC. It will convert up to 35 volts of DC. That DC will be given to the MOSFET board. So MOSFET board will work as a inverter. So we will give the pulses. We know that inverter works. It will convert DC to AC current. So the pulses, this MOSFET pulses will be given, gate pulses will be given by this Arduino Uno. So the pulses will be given within microseconds. So we maintain that 200 microseconds for the gate signals. So we are giving the signals from 12-11 pins. So the 12-11 pins are connected to the gate pulse of this MOSFET board, and also one ground is commonly connected to the Arduino Uno. After that it will also, so one of the here we can see there is a two different MOSFETs. One is a N channel, another one is a P channel. So here also N channel, another one is a P channel. So one MOSFET will be generated positive wave and another MOSFET will be generated negative waveform. In this way the AC signal will be, the AC power supply will be generated, that will be given to this capacitor board. So capacitor board will improve the voltage up to 35 volts to 40. Then it will given to this coil. This is a transmitter coil, here we can see. So it will take in the 35 volts of 35 to 40 volts of AC power supply from this capacitor board. Then it will be received by this receiver coil. So receiver coil will receive the AC power supply. That AC power supply will be converted into DC. So here we can see the rectifier and the capacitors. It will convert AC to DC. So it will here we can see the capacitors. These are the 200 microfarad capacitor with 24 volts which are connected in series. Now this voltage will be improved up to 50 volts. That 50 volts will be given to the 8051 regulator with the microcontroller and also given by the voltage sensor. So voltage sensor will sense the voltage from the transmitter coil, and also the transmitter coil, the receiver coil is connected to the voltage sensor. So it will monitor the receiver coil voltage, and also the receiver coil voltage is connected to the PIC microcontroller. So based on the receiver coil voltage, this PIC microcontroller will be works, and based on the receiver coil voltage, it will give the readings from the LCD display. So let us see how it will be works. So first of all we need to on the power supply for the Arduino Uno. It will generate a pulses. So if we give the power supply to this Arduino Uno, then it will be generating pulses. So if sometimes it may not give pulses, so we need to reset this one again, so it will give pulses. So here we can see the light indication. So this light indication means it is generating a pulses. So that generating pulses will be given to this MOSFET board. So we are providing the power supply now for the transmitter coil. So here we can see it is taking the DC power supply from this rectifier and will convert it into AC. That AC will be given to this transmitter coil. So here we can see. So here we can see it is generated a AC current, and AC current will be received by the receiver coil. So we can see so now here we can see. So the coils are near by each other. So the voltage is 50.8, and if I increase slowly this voltage distance, we can observe. So 40 volts, 46 volts, 42 volts, 35 volts, 31 and 28, 24, 21, 20, 17 and 14, 13. And if it is more than if it is less than 12 volts, then the system will be have a low voltage. So here we can see the light dim light indication. So actually the system will be works on the receiver coil. So that's why for this distance it will be this receiver coil may not receive any power supply for if we maintain a low distance. So here we can see again system is working on. So we can see the voltage values. So here we can see it is increasing if the distance is decreasing. So we can see 15, 18, 24, 32, 40 and 50 volts. So I have to maintain some distance. In this way this product will be works. Thanks for the watching.